This is a video from section 3.9. It's on related rates, and we're going to look at example 1. The radius of a sphere is increasing at a rate of 4 millimeters per second. The question says, how fast is the volume increasing when the radius is 40 millimeters? So, I'm going to identify our variables. And so we're going to let r be the radius of the sphere. And we're going to let v represent the volume. And we know that v is 4/3 pi r cubed. So this is the volume of a sphere. So we need to know that. Now, we know dr dt, we're always differentiating with respect to time, by the way. T is time, is 4 millimeters per second. So we know dr dt is equal to 4. And again, that's millimeters per second. Okay? So we want dv dt when r is 40. So this is a direct application of section 3.5 when you did implicit differentiation. So what you're going to do is you're going to start with v equals 4/3 pi r cubed. And we're going to take the derivative of both sides with respect to t. So we're going to differentiate both sides with respect to t. T is time, okay? And so dv dt, now I'm going to apply the power rule. So 4/3 pi is a constant, and the derivative of r cubed is 3r squared. But remember, you have to multiply by dr dt. And so dv dt is 4 pi r squared dr dt. So when r equals 40 and dr dt equals 4, then dv dt is 4 pi times 40 squared times 4. But 4 times 4 is 16, so this is 16 pi times 1,600. Okay? But 16 times 6 is 256. And so, therefore, dv dt is equal to 256 followed by 2 zeros, so 25,600 pi. And so, in conclusion, we can say this. The volume of the sphere is increasing at a rate of 25,600 pi. Now, the units of volume are cubic millimeters. So it's going to be cubic millimeters per, the units of time is seconds. So it's cubic millimeters per second. And that right there is how you do example 1. Let's take a look at example 2. The altitude of a triangle is increasing at a rate of 1 centimeter per minute, while the area of the triangle is increasing at a rate of 2 square centimeters per minute. At what rate is the base of the triangle changing when the altitude is 10 centimeters and the area is 100 square centimeters? And so I'm looking at rate of change, derivative. And so we're going to let h equal the altitude of the triangle and b equal the base of the triangle. And so the area of a triangle is 1/2 the base times the height, or 1/2 BH. Okay? Now, if we go back, the altitude of a triangle is increasing at a rate of 1 centimeter per minute. So we know dH dt is 1. And dA dt is 2 square centimeters per minute. We want dB dt when h is 10 and a is 100. So let's go back to here. A is 1/2 the base times the height, dA dt. So again, differentiate both sides with respect to t. So we're going to take 1/2 times b times dH dt. So I'm applying the product rule. Here, we're going to do it in the order you guys are used to. So I'm going to take the derivative of b, which is dB dt, and I'm going to multiply by h. And I'm going to add b times dH dt. Okay? Now, we want dB dt. Okay? We want dB dt. We know. So if we go back, we know dH dt is 1. dA dt is 2. So when h equals 10 and a equals 100, we have, let's go back, the following. So I'm just going to start plugging in information. So let's go ahead and rewrite this. dA dt is 1/2 of dB dt times h plus b times dH dt. So I'm going to look back. dA dt is equal to 2. So I'm going to write a 2. And I'm going to go 1/2 times. I want the derivative of b with respect to time, or dB dt. So we don't know that. So I'm just going to write that down. Now h is 10. Let's write 10. B, interestingly, we don't know b, but I'm going to explain how we get that. So we're just going to write a b here for the moment. And then dH dt is 1. So b times 1. Now, we don't know b. But we do know the area is 1/2 the base times the height. We do know that. And we do know the area is 100. And so this is 1/2 b multiplied by 10 because the height is 10. And so 100 is 5b, or b is 20. So that's the b we're looking for. They gave us the area and gave us the height, but that allowed us to find the base. And another name for altitude is height, by the way, okay? So I'm going to come over here, and I'm going to write the following. I'm going to write 2 is 1/2 of, this is 10 times dB dt, plus b. But remember that b, we just solved it. B is 20. So I'm going to put that in, and I'm going to distribute the half. So 2 is, now half of 10 is 5. So I'm going to take 5 times dB dt plus half of 20, basically, which is 10, right? So I'm going to move the 10 over, and I'm going to get -8 is 5 times dB dt. And so dB dt is equal to -1.6. Now the question is, what does that mean when you get a rate of change that's negative? So let me explain that. So the base of the triangle is decreasing. So when it's negative, it's decreasing. When it's positive, it's increasing, okay? At a rate of 1.6, and the units here are centimeters per minute. And that'll conclude this video for section 3.9, and we looked at 2 examples of related rates. Thank you.